Suppose you receive a $10 off coupon in the mail for a clothing purchase at your favorite store. However, the store is also running a promotional deal this week that gives you 20% off your purchase when you use their credit card. Write a function for the purchase price of an item with each discount. Then use your functions to determine which discount should be applied first to give you the best deal. Alright, so the first part of this question is asking us to write two functions. One that will represent the purchase price if we use the $10 off coupon, and the other if we use the 20% off. So, first let's identify our variable. We don't know the cost of the item, the initial purchase price, whatever we're purchasing. So we'll go ahead and let X be that initial price. So let's let X be the initial price of our item, whatever we're buying. Initial price of the item. And let's go ahead and call C my coupon. So we're trying to write a function for C of X. If you use the coupon, which is $10 off, then what's the new price going to be for your item? So for example, if we had a $50 item and we used the coupon, we're going to get $10 off, and my new item is now $40. So we're going to be taking the initial price of our item, X, and subtracting $10. And that's going to give us the new price when we apply the coupon. Then the second deal is if we use the 20% off when we use the credit card. So I'm just going to call that P for percentage. So what does the function look like if we apply the 20% off? So again, maybe it'll help you to do numbers first. Say you bought a $40 item, but it's 20% off. So 20% of $40, so you would multiply by 20%. But remember, that's not going to be the actual price of the item. That's the amount of your discount. So that ends up being $8. So really, we'd have to take the initial price of our item, and then we would subtract that value to figure out our new price. So that means we would have taken 40 minus the 40 times the 0.2. So if you generalize what we just did, if the initial price of my item was X dollars, but then I'm going to have to subtract off the discount, and the discount is 20% of X, then that looks like X minus 0.2X, which if you simplify that, that would give you 0.8X, which should make sense to you because if you're getting 20% off, then you're going to be paying 80% of the original price. So if you use the percentage, then our function would be 0.8 times X. Alright, part A is completed. We have our two individual functions. So part B, the question is, which should we apply first? Should we use the $10 off coupon first, or should we use the 20% off, the percentage first? Which one's going to give us the best deal? And you initially might have kind of a gut instinct here about which one you think you should apply first. And maybe you'd want to play with it with a number initially and choose a value and see if your instinct was right. For example, if we were to just pick, let's say we're going to have a $100 item. And this is not going to be my answer to part B, but just us thinking about what's going to happen. Let's say we have a $100 item. If we use the coupon first, that would be C of 100. So our $100 item, we get $10 off. Now it costs us $90. And then if we apply the percentage on that $90 item, we'll be paying 80% of $90. In other words, in the end, I'd end up with an item that cost me 72 bucks. But if you did the percentage first, so let's say you start with your $100 item. So the percentage first means that we'd get 20% off that $100 item. So now that item's going to cost $80. And then if I use the coupon on my new $80 item, I'm getting $10 off that $80 item. So now my final purchase price is $70. So now you can look at your two ending prices here and see if this matched kind of what your instinct was. Obviously, we end up with a cheaper item when we apply the 20% first and then the $10 coupon second. But this is only showing that this is true for one initial price, my one item that initially cost me $100. And we want to be able to show that this is going to be true in all cases. Now the math that we just did in both of those cases was actually a composition. So let's look at this and generalize. Let's see, what would it look like if we did the coupon first, the $10 off coupon. So in terms of a composition, if we wanted to apply the coupon first, then the composition would look like this, P of C of X. And remember, with compositions, we're always going to be looking at the inside function. That's telling us what we're doing first. And since C is on the inside, that means I'm going to apply the coupon first and then take the result and apply the percentage. So let's go ahead and actually do the algebra here. So we're taking the coupon function and it becomes your input. You're substituting it into your P function, your percentage function. So that would be 0.8 times the quantity x minus 10, which if you distribute, then you get the value or the expression 0.8 x minus 8. So that would be the new function if you apply the coupon first. And now let's compare that to the function that we'll get if we apply the percentage first. So in terms of a composition, that would be C of P of X, because now P is here on the inside. And so that's going to reverse our substitution basically. Now we're going to take this function P and it's going to be substituted into function C, which is going to look a little different. So that's going to be 0.8x minus 10. And now we're comparing these two functions, these two boxed functions that we have. And which one is going to give us the smaller number? Well, they both have 0.8 times x, but then you can see that in the percentage first equation, we're subtracting 10 compared with only subtracting 8 in the other equation. So therefore, we're going to end up with the smaller value here using the percentage first. Therefore, we've now proven that the best deal will always be to use the 20% off percentage first and then apply your $10 coupon.